yeah, anyway, so slope's rate of change. We've talked about this before. This is all review. There's going to be one little twist to this towards the end of the slope part that I'll get with you guys. But what I want to do today is just kind of, what did slope mean? What was slope? What did it mean?
It's rise over run.
Rise over run, perfect. When you say rise over run, are you talking about what values, x's or y's? What's rise?
Rise and
Y, correct. And then that means by process of elimination, your x values are the, I hope you don't have to run. Sorry, that's just bad. Anyway, so rise over run. Now I'm going out on a limb and I'm going to assume you've all seen this before.
Yeah.
What does that mean?
It's change in y over change in x.
Perfect. Change in y over change in x. Delta is the Greek symbol for change. When you're dealing with slopes, remember you're dealing with a set of ordered pairs. You've got two sets of x, y coordinates. First set of x and y's, second set of x and y's. And more often than not, you have probably seen the equation to solve for the slope of a line as the slope is equal to the change in x values divided by the change. Did I say change in x? I meant change in y values divided by the change in x values. And we've all seen that before. We've all used it. That's not new to us. The biggest mistake that students make when they're working with slopes is you might accidentally flip-flop an x or a y value. You might forget a negative symbol here or there. So the best advice that I can give you guys when you are just finding straight slopes of problems, just slow down. Just slow down, okay? The other thing that we talked about in third hour was there are 4 types of slopes. What's one of them? Louder. Positive slope, okay, there's one. That means the other one would be
Negative.
negative, and then
Oh, horizontal.
Undefined.
that would be undefined. It would be undefined, yeah. And I heard someone else bring up the word neutral slope before. Where did you guys learn that
also
from?
do like, I don't know, just mix degrees of concepts, I guess.
Yeah, I mean, no, I'm just curious. Did the teacher specifically call something a neutral?
I don't think so.
Who was? I'm just
Oh,
curious.
that was
Because I've never heard it before until last hour or third hour when someone else said neutral slope. I'm like, huh? And that's for your horizontal line, right?
And then is there the one? Then there's like the palette or the collab or something that goes in the circle, right?
That's a parabola. It's down like a frown or up like a cup.
That's what I mean.
Remember that? Down like a frown or up like a cup.
That's slanted.
That's a smirk. Yeah, we'll just do that. Yeah. So your positive slopes always go up and to the right. You agree?
Great.
Negative slopes are always down and right. A horizontal line has what value of slope? 0. Do you know the easiest way to remember that?
Nope.
What's the second letter in the word horizontal?
Horizon.
Oh.
That was
Oh, you can also say horizon.
Right, or horizon, but it's 0. It looks like it's 0.
That's how I say it.
Yeah, no, that's fine. That's perfectly fine. And then obviously the last one is the vertical line, and that is the undefined. And if you want to just write it as UND, perfectly fine by me. Now, when we're dealing with slopes, they're always written up in fraction form. You're never going to see a 2/3 or a 0.667 slope. You're going to always see it written as 2/3, or you're not going to see 0.25 as a slope. You'll see it as 1/4. So when you get to your 0 or your undefined slope, think of it as a fraction. And in order for the slope to be equal to 0, what has to be equal to 0, the numerator or the denominator?
Oh, well, no.
Numerator.
The numerator would have to be 0. Because can you divide by 0? No, because that is the undefined slope when it's 0 in the denominator. So A quick way of realizing when you have a horizontal line or a vertical line is in order to have the same, or in order to have 0 in your numerator, that means your x coordinates for your ordered pairs would both have to be the same value. Also goes the same logic if both your values are of the y values are the same. That means you'd have an undefined slope because it's a vertical line. Okay? So it's an easy way of looking at some of those things. You'll see that from time to time, especially when you guys get to like ACT stuff. Those quick questions that they'll throw at you with slopes like that, they'll make for the same value in there instead of having to recalculate the whole thing. All right. Speaking of slopes and everything, we also remember that the equation was your slope, change in y values with a change in x values. Now, do you have any idea why they chose the letter M?
It's
Roman.
No.
No,
Look at the word slope. What's an S look like? A 5. It can look like a 5, right? What does the L look like?
Straight.
A 1, so you're not going to use that. An O looks like 0. In math, what is P used for? Perimeter or probability?
yeah.
The probability. You talk about probability a lot, and then E, the exponential function. So what they had to do is go through the entire alphabet to find a letter. So think about A, B, and C. What giant formula uses A, B's, and C's? Pythagorean theorem, right? D, distance formula.
Also,
Yeah.
quadratic.
Quadratic stuff, yeah. E is being used, F, they weren't going to use F because F is used all the time as function. F of x, function notation. G of x is the same idea. I, we use I for imaginary numbers. Do you guys know that there's such a thing as imaginary?
Yes.
We actually do some study.
Square root of negative.
Yeah, square root of -1, so they can't use that. So what they did is they just kind of went through the whole entire alphabet until they found a letter that worked.
What is Z?
They stopped at that. They got M first. I'm going out on a limb here and think that M comes
Z is
with.
a coordinate, so.
Yeah, you're right. And Z's a coordinate.
Oh. Screw that.
See, you learn something new every day. Did you guys ever hear that story? It's a disservice that you guys never heard that.
Actually,
What?
I think I did. I just forgot
Well, you never heard that story because I just made the whole thing up.
it. Did you really?
Yeah.
Is there,
I
do
don't
you
think
know
it's-
the real
is it
reason why
M
it's
or
a
N? Point formula?
Someone told me, someone else told me.
I think
and
so.
No, seriously, I made that up. I think the guy that made it up, that came up with slope, his name was Murphy. What do you know about parallel lines and perpendicular lines when you're dealing with slopes? Yeah. You guys remember seeing these two symbols, right? The slash and then the perpendicular symbol? No? Really? Come on, you're killing me. All right, parallel lines, they have the same slope. And then perpendicular lines are the opposite reciprocals slopes. For example, if I have an original slope, you'll hear me use that term a lot. If I have an original slope of 1/2, what's my parallel slope? 1/2. And then what would be the perpendicular slope? -2. There's a reason why I write it out as original slope, and you made the case for doing that. And I'm going to explain that when we get to the 2.4 stuff. There's a real big reason why I like to do that. The only other real part of slopes that you guys tend to, that might be a little bit new, is sometimes you're going to find a missing value given the slope. What I mean by this is we all agree that when you have a slope, you can be given a slope of 1/10. You can be given one set of ordered pairs at 4 and 2, and then the other set of ordered pairs is at 14 and something. What you want to do is figure out what that something is. So the twist that you guys are going to have today isn't just going to be calculating slopes, because that tends to be rather tedious and it's kind of the same thing over and over and over and over again. So what we want to be able to do with you guys now is push you into the fact of trying to solve this. we know the slope is equal to change in y over the change in x. So now we have, well, there's 5 variables in this equation. I know 4 of them. Substitute in and solve for the missing variable. My slope is 110. My y values are something minus 2, and the other one is 14 minus 4. Now, in this case, you might recognize there's a really easy way of doing it. What's 14 minus 4? 10. So if I simplify this right away with one step, in order for these to be equivalent fractions, the numerators and denominators have to be the same. Yeah. So you just have to set 1 equal to y minus 2, and you guys all got 3, correct?
Yeah.
Okay, good. Now, what you also just did, without realizing what you did, is the following. Whenever you have fraction equal fraction with an equation, how do you solve that?
Cross
Cross multiply.
I was thinking that, but I wasn't sure.
It was right. So you can continue to think that. So, in essence, what you just did was this. In this case, it's too difficult to go that route because it's too many steps. All right? But in essence, that's what you just did. So what I want you to do now is take that same idea of cross multiplying, because it's fraction equal fraction, and solve this one. And I'm going to pause this while you guys are working. C. Hopefully it started like that, right?
Yeah.
Okay.
Yeah,
Now, since the slope is just -1, that means the denominator is also 1. We're okay on that? And that's what a lot of people tend to forget. Even if, let's say your slope was 8, you just put that over 1 and it's going to work out just fine.
Alright, I put the X on.
Oh. So cross multiply out, you get -1 times -6 minus x is 4. We okay with that? Distribute the negative. 6 plus x is 4. Did you get -2?
Yeah.
I did get -2. I didn't do it right.
Sometimes the wrong mistake is right.
Yeah.
I guess you.
All right. So that's usually where we're going to be at with some of these things. Don't be surprised, instead of having just a value of x, I might have an x here and a 3x here. You have to still work it through the same idea. You'll have variables on both sides of the equation. So it just gives you an extra step. So, really, in all honesty, that's all I have to show you guys with slopes. That's kind of why I wanted to just blend this into working with writing equations. Now, I will give you guys credit. This was probably the first time I've asked the questions about slopes in a long time. Before someone actually, when I first asked what is slope, that someone didn't say y equals mx plus b. Because usually that's the first response that I get when I ask kids about slope. Because it's ingrained in your brain to always talk about slope-intercept form. Y equals mx plus b, y equals mx plus b. So,
Change it.
one brain at a time. Let's talk about that then. Slope-intercept form. Why is slope-intercept form your best friend in the whole wide world?
Because the base would be easy to solve.
It's very easy to solve. Even more importantly, there is a fancy button on calculators. Yeah, it says y equals. If you can get an equation into y equals form, you can press a button on your calculator and graph it. By being able to graph the calculators, graph the equation on the calculator, you can get so much more information out of it. You're going to be able to use the table function. You'll be able to plot points. You'll be able to find intersection values. You're going to be able to figure out where systems of equations, where they line up, they run into each other. But it all stems from being able to put stuff into slope-intercept form. That's why it's a very important form that we all use. And like I said, slope-intercept form for us is not a real new concept. it's kind of the standard, if you will. So let's see, we got slope, change in y, change in x, slope intercept form. What does the m stand for again? What's the b?
Y-intercept.
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 Okay. And then the last part there is point slope form. When do you use point slope form? A point and slope. I know it's. You use point slope form whenever you have a point and a slope. For example, xy is your point and your slope is m. Do you remember what the generic form of point slope form looked like? What happens here is that in your generic form of point slope form, this is the only set of ordered pairs you get. You have one set of ordered pairs, x, y. You use that in conjunction with y minus y sub 1 is your slope times x minus x sub 1. What's that? That's what point slope form looks like. To be honest with you, I think point slope form tends to be much easier to work with, especially when you're trying to write equations of lines that are parallel, equations of lines that are perpendicular, things like that. This marker's about dead. So it's a little bit more useful to use. One of the things that we're also going to talk about is that point slope form is nothing more than a shifted version of a slope intercept form. And we'll discuss that as we get to more into shifting graphs throughout the school year. So let's take an example of point slope form and write it out before we get to parallels and perpendicular. So what I want to do here is I'm going to be giving you the point and the slope, and I'd like you to write it into slope intercept form. So that means in order to write it into slope intercept form, you first substitute into point slope, and then just solve for y. All right? So in this case here, we have 2, 3 for your ordered pairs, and your slope is negative 1/2. Those are your x and your y. So y minus 3 is negative 1/2 x minus 2.
Right.
Distribute and solve for y. And then how do you move a negative 3? That's right. I said 1, didn't I? Okay. And like I said, you've all done this before. You've all done this. Vaguely remember it now?
Well, how do you do
He's got out of sequence here. Sorry about that. What changes if you're given just 2 points? What do you have to do first?
Find the slope.
Find the slope. Yep. So if it changes, you still want to write the equation of the line that passes through these 2 points. He's leaving high and dry.
it? Wait.
I can tell. Remember, the first thing I do is find your slope. And then use point slope. Now, does it matter which point you use after you find your slope when you're using point slope form? It doesn't matter. So whenever you're given a pair of points, you got to write it out in the equation. You always start out by finding your slope. So let's see here. 4 minus negative 1 over 3 minus negative 2. And last time I checked, 5 over 5 is 1. Okay? So now you know what your slope is, and you have a pair of points. It makes absolutely no difference which one you choose. If you choose the negative values, instead of writing it out as y minus a negative 1, what should you write it as? Exactly. So you have y plus 1 is x plus 2. And you'll get the exact same result if you use the other ordered pair. It does not matter. Right? It does not matter. Okay. Any questions on that? All right, let's go to the fun stuff then, because I know you guys are dying for it. Writing equations of lines that are parallel and perpendicular. Write equations of lines that are parallel or perpendicular. Now this goes back, I know that there are other ways of doing this. We talked about this third hour. What I like to try and do with these things, and I've set this up the exact same way no matter what level I've taught, whether it was pre-algebra, algebra, advanced algebra, or you guys. I always, in geometry we did the same thing. I always try to present it the same way, because if, in math, if you follow the same progression of steps, more often than not, you're going to get it right. So whenever you see a perpendicular or a parallel problem, the very first thing you want to try and do is always ask yourself the following. Parallel or perpendicular problems. First thing you always want to do, what is the original slope? Yeah, in this case, my original slope is 2. The second thing I always ask myself, is it a parallel problem or is it a perpendicular problem? By adding that step in there, remember earlier when you told me that the slope was 2 and I was asking for a parallel when it was negative 1/2 again?
Yeah.
By putting this in here as one of my steps, it forces me to go back and reread the question. Is this a parallel or is this a perpendicular problem? It's a perpendicular problem, which means I need to find a perpendicular slope. So what's the perpendicular slope to 2? Negative 1/2, good. And now just use point slope. All right? Just use point slope now. So by forcing yourself to slow down and ask this second question, is it parallel or perpendicular, you'll be less likely to make any mistakes on these things. So we use point slope. Y minus 4 is negative 1/2 times x plus 3. Okay? Now I want you guys to try and solve, and I want you guys to take out your calculators with this one. I want to show you how your calculators are able to work with fraction rather easily. Remember how we set up the calculators? I showed you guys the calculator stuff last week where you had that alpha y equals button?
Yeah.
The alpha y equals will get you to the fraction bar, and that'll allow you to type in fractions. Okay? Now in this case, it's relatively straightforward. You still have y minus 4 is negative 1/2 x minus 3/2. And the only scary thing that I have to be able to do here is take negative 3/2 and add 4 to it. So if you're using the TI-84s, let's clear this out. If you're using this one, If you go to your alpha y equals, it comes up with that menu screen of a couple of different fractions. The first one is what we're looking at, just the n over d, Notre Dame, numerator denominator. That's how I always remembered it. You just hit enter, and it creates that fraction. Basically, it's the same thing as what you have in your hand with just that one fraction button. It'll do the same thing. Was it -3 over 2? Then you just hit the button to the right to get out of the denominator. And I think we had to do what? Add 4? If you add 4 to it when it's already written as a fraction, it's going to spit out a fractional answer. Because you told it that you're inputting a fraction, so it's going to export a fraction. Now, some of these things are relatively simple as far as the decimal equivalents are concerned. I know that a lot of students, they might just write -1.5 plus 4 and get, 2.5?
Yeah.
Well, if you do it that way, if you take that -1.5 plus 4, it'll spit out the decimal. In order to reconfigure that to a fraction, because I like fractions, they're better than decimals, math, enter, enter. It'll re-go. Okay? It'll take a little bit of a learning curve. I'm not accustomed to the 84s. But that's how that works. Yes, sir?
Are we gonna get the inspires or?
I don't think so. I don't think there's enough numbers, enough of them to go around. We might have to wait till second semester. So that's what it's starting to look like. I know. I thought we were going to have enough, but it looks like we're probably about 30 short.
That's all right, we should,
Hey, you like our class better, right?
yeah,
Yeah, but I don't want to. I don't want to have to teach 2 different calculators. You know what I mean?
right, yeah.
Because then there's certain things that we can do in one class we can't do in others. So I just rather keep everybody at the same level. I mean, if you have one, you can bring it. That doesn't matter to me. Like,
I don't have one.
I don't either. All right. Any questions about how the calculator works on these fraction problems? Hopefully relatively easy. So take a second and solve this one. This is it. Write the equation in the slope-intercept form that is parallel through that point. I'll give you a minute or two to do that. So the original slope is -3. It's a parallel problem. So you get y minus 2 is -3 times x minus 3. -3x plus 11.
Yeah.
Yeah.
Yeah, no,
All right. Now, don't think that every single problem is always going to start out right away in slope-intercept form. Sometimes they do start in the standard form, that ax plus by equals c. Standard form is really nice for when we're doing some quick graphing, but that's about all it's ever good for.
I don't like that.
I really don't. There's one good reason for standard form, and I'm going to show you that probably Thursday. Yes, sir.
Do you guys use notes on quiz like set?
No,
No.
I'm a jerk. No, there will be times. There will be times that I will allow like a note card, but it's not a reoccurring thing.
I got you.
And I'm not really a jerk. It's just geometry is much tougher. We'll say that, right?
I guess.
I do have one new thing to discuss with you guys today. This is called direct variation, and it's relatively straightforward. Direct variation is kind of like a precursor to slope. A lot of textbooks use it as the first lesson when they get into linear equations, because that value of k, it acts as the slope of a line with a 0 for a y-intercept. So what happens here is you're going to see some new writing. Direct variation always uses the same equation. Y equals something times x. That k value is some constant. Okay? Think of it as a slope if you want. What you're going to see in a problem is the following language. X and y vary directly. Then you'll see the next statement. Y equals something when x equals something. In this case, it says y equals 12 when x is 4. So if I'm looking at this equation, I see 3 variables. Do you agree? Y, k, and x?
Yes, sir.
All right. If I've given you y and x, what's the one variable you have to solve for? Okay. In this example, what is the value of k? 3. Now what they're making you do is reuse this value there. Because it's asking you the next question. What is y when x is 5? So once again, y equals k times x. Now you know what the value of k is, and you know what the value of x is. So y is 3 times 5, which is 15. This direct variation stuff, we use direct variation, inverse variation, joint variation, things like that. We use this a little bit more second semester in chapter 10. And I don't really remember what chapter it is. But I just want you guys to think of the idea is that this, when you see this stuff called direct variation, it's kind of a precursor to what slope is. There's no variance as far as the y-intercepts are concerned. It's always through the origin. It's just changing the steepness of the value. That's all it is. Okay? That's all it is. I think I have one more like this. Yeah.
We have more time.
Yeah, I have 15 problems maybe. It's nothing.
It's not.
And so here's another direct variation. We'll just walk through this last one, then I'll give you some problems to do. X and y vary directly. X equals 2 when y is 7. What is y equal to when x equals 8? So once again, we set up the generic formula. Y equals something times x. In this case, 7 is 2 times k. 7 halves. And is it all right to have a fraction for that? Yeah. It's the same idea as a slope, up 7 over 2, up 7 over 2. You reuse it again. That value of y is equal 7 over 2 times 8. And you're done. You guys all right?
Yeah.
You sure?
Yeah.
All right.
Genuine.
It's just a new way of looking at it. They just use that value. They use that value of k. It's like I said, it mirrors the use of slope. All right. Let's try a handful of these problems then for tonight. One of the things, like I said, all the book stuff is online in the PDF forms. Some students still, if you want, instead of going online to do that, if you want to take your phone out right now and take a picture of the book pages, by all means, it's perfectly fine. I will show you again how you can find them on the website. The section 2.2 is page 81, numbers 55 through 58. And then the section 2.4 is page 95, numbers 25 through 28, 38 through 40, and 43 through 54.
This is our only homework for.
Yes, sir.
Okay.
That's it.
This is for tonight?
Yeah.
Oh, that's fair.
Yeah, like I said, they make about 15, 16 problems. You should fly through most of them. It's just some quick writing equations and whatnot. Remember, if you are going to the website to find where the pages and stuff are, I'll walk you through it again. Yeah, I will. Sorry. Jeez. Remember, if you're on the website, Chapter 2 tab, Section 2.2, all you do is click it, and it pops up, and you just scroll through the page.
Could you do like a check-in thing for this tomorrow?
Yeah, we'll look at it tomorrow. And it'll be in here somewhere. All right? Yes, sir.
Is there like a login to get on the board?
No, there isn't. If you go right to the website, it should link you right in there. I know that if you were using Safari, there might have been an issue, but if you use Chrome, there shouldn't be. All right. I know that there was a problem because there was one page that I forgot to make public, so I think I found that page. If there is another one, just let me know. Yes, sir. Yeah, I was gonna stop recording.